All right, today is the introduction day to Project 137. And in this project, you're going to show the things that you have learned from the last few days of class. This is once again a project that will be done in your engineering notebook in its entirety. And when you are doing this project in your engineering notebook, you should make sure that you are, number one, following the rubric, because the rubric will give you the most points possible, making sure that you understand every step and every point and how you get those points. That way you will get the best grade that you can when you are finished doing this project. Because this is an end of the unit kind of project, in your engineering notebook you will have a defined problem. And I actually have these right here better, easier to see. So that is the first thing you're going to do, is define your problem. Then you're going to generate some concepts. I think there's a minimum of 3 for this project. You will have to then develop a solution. You will then construct and test. We will print them. You will evaluate how you did. And finally, there will be a present solution where you would write a small paragraph about how the overall project went. So to jump right to that rubric, the rubric is right here. Same thing that we always have in a rubric. It's 25 points total. Name, title, signature, date. I check the entire engineering notebook. Make sure that as you are going through that you have all of these things completed. These are easy points. 1, 2, 3, 4, 5, 6 out of 25 points is based on making sure you have basic things done in the engineering notebook correctly. We're going to clearly state the problem. I am supplying you with a design brief for this one, since I am not here and in class to be able to do that today. So make sure that you define the problem in your engineering notebook. You're basically just going to take this design brief, which is right here. Design a protective case design brief. It's right here. You're going to take that and copy it into your engineering notebook. You do have an opportunity to add a constraint. This is something that you're going to add that's your own constraint. It's not already in there. It's something that you can add to the project to make it more challenging, so that when you complete it, your constraint may or may not be met. Because remember, at the end, you're always going to have your checklist saying if you were able to do those things or not. And then maybe a little research. I'll show you what that research looks like in just a moment. Usually take it for, face value that you do some research when you're doing this. So here is the design brief. The problem is that there's some consumers that when they are putting their earbuds in and out of their case, the wiring, so this is kind of old because we don't have earbuds with wires in them anymore, but we'll pretend the wires are getting damaged. And because the wires are getting damaged, we are supposed to solve that problem by developing some kind of a case. So the case that you're going to have has to have 2 parts to it with a hinge mechanism. This is a partner project. One person is going to work on the top of the case and the top only. One person is going to work on the bottom of the case and the bottom only. And you guys are going to have to discuss and talk about how you are going to make that hinge mechanism work. That's part of the project, is that you're going to work with somebody to make sure you have that. The design should be so that a worker can easily get the earbuds into the case and out of the case, and it should be secure where it holds them in place. The earbuds should be something that's protective and will allow the earbuds to be in it and not be damaged. There's going to be some vent holes that will allow for air circulation. And here you go. A place for you to put your own constraint, whatever that is, anything you want. Sky's the limit. And another spot for you to put a constraint that you would like. You have to have 6. So in the project, in the define the problem, constraints properly documented, and you added one. The constraints are properly documented and you added one. The design has to be submitted by whatever it says on Schoology. I'm not going to say a date out loud. because I might use this in future years and dates will change. So look on Schoology. There is a date on Schoology that it says when you have to have your STL file turned into me so that I can 3D print them. We will 3D print them. You don't need to write a date down for that, but check on Schoology for this one. And due to limitations, we're going to say the size of the project is something similar to an earbud case that already exists. It should be something that fits comfortably into and out of a pocket. So you don't want to make something that's incredibly large and does not fit into or is able to be easily taken out of a pocket. And that should be everything that you need for your design brief. So maximum volume, something that goes in and out of a pocket easily, must be submitted by the STL file. Check the due date on Schoology. I am closing that because I don't need to have that out anymore. When you brainstorm your ideas, you are supposed to come up with 3 conceptual sketches for what your case might look like. I will be honest with you. I'm not sure how you get 3 different designs, and by challenging people to have 3 different designs in the past, they've been very creative and have come up with some really interesting concepts for what their case would look like that has some type of a hinge mechanism. The hinge mechanism should be a plastic style hinge mechanism. What I mean by that is, if you go on to Schoology, there is an example of what the competitor's top and the competitor's bottom looks like for their case. Obviously, you don't want to make that, because if you make that, you're going to end up with the same exact thing and you're going to have the same problems that they had. But if you notice here what the hinge looks like, it's kind of got this tube, and there's an indent here and an indent there. And if I go and get the bottom of ours looks like this, where if I can zoom in a little bit, there's a little knob that sticks out there and one that sticks out there. See the little knobs? So that little knob on that one goes into, that's not a hole, that's a little button that's popping out. That little knob goes into the hole on this one. So the little bulb on one end goes into the other one. And it's a very common hinge. As a matter of fact, it's so common. I have one right here. I'm going to try to make my camera big here for that. That'll work. This is just a screwdriver set that I found at the store, and this exactly does have those kinds of hinges, where if I open up the case, it opens up just fine, and I can actually pop it apart, because on one side you have the plastic little nub. If I can get that to focus, you can see it there, that little plastic nub on there. And then on the other one, you have the little holes, that it goes into. So you can see those holes on that one. So when they go together, they do clip together like that, and then they stay. Oops, they don't stay. They clip together like that, and then it stays together. And that's what keeps the case working. So that's what we're after on this one. And like I said, even though you have the competitor's case here, you don't want to follow it exactly, because theirs was bad. We want to make something better than theirs. But you can use this for inspiration. They have some holes there for air vents. You can put the air vents on different sides. You can make the lid different. You can make it more round. You can make it more octagon. You can make it more rectangular, less rectangular. You can come up with any kind of design you want in terms of shape and style and where you want the air vent holes. So I'm going to make these go away. All of that is available. Everything I'm showing you is available. Here's the rubric. Here's the overall directions. Here's the design brief and the competitor's case. I'm going back to the rubric. Concept sketch 1, 2, 3. Basically, it'll probably be something similar. With different shaped boxes, or maybe you have the air vent holes different sizes or in different locations. But if you have 3 conceptual sketches, you'll use a decision matrix then to decide which one you are going to do with your partner. In theory, this is how far you should get today. Today, on the day that we're introducing the project, you're watching this video, and you should get to the point to where you have your decision matrix done. So when you come into class on the next day, you're ready to start working in Fusion and designing your case, which means you're going to spend the next 2 days of class working in Fusion, getting your case done, working with your partner, making sure that your case and your partner's case are going to work together, and talking about how they fit together and those kinds of things. Don't forget to document that you're working in Fusion 360 and the dates you're doing that. You will put the case onto a multi-sheet drawing. Once you do that, you will have to dimension the case properly. That's worth 3 points in the project. And you should have some note on that dimensioning page that shows what the material is made out of. This day that we're doing it is day 1. Day 2 is entirely a work day for you in class to be able to work on making your case, whether you're making the top or the bottom. Day 3 is entirely a work day to work on the case, whether you're making the top or the bottom. After day 3, that is when the STL file should be submitted, and I will work on printing them. And once they are printed, we'll check that all the criteria have been met, and you will complete this project with a 1-paragraph proposal. So I'm going to make the rubric go away so that you can see it. Everything here is the same information I just presented to you in the rubric with a lot more words. So if you want to look at this to get some more clarification about what you're supposed to do in different steps and how it's all supposed to fit together, feel free to take a look at this and read it. But at this point, you should work on getting that design brief copied into your engineering notebook. Then you should work on coming up with 3 concept sketches and a decision matrix so that by the next class period, you are ready to work in Fusion 360. Good luck with the project, and I will see you in a few days.